This is our AB Calculus second 6 weeks test on limits through normal lines. In problems 1 through 6, a function is given. Find the first derivative of each function at 1 point each. What we have to do for this set of exercises is understand what a derivative is and how to find that derivative. Not that you have to make this certain notation that I'm going to recommend at this point, but it really is preferred. Okay, what you have is you have an original function f of x, and the first derivative you would normally write as f prime of x. And so the first derivative of 2x minus 3 is going to be simply 2. So you have 2x to the first power, 1 times 2 is 2, then you have x to the 0 power, and then we have 3 as a constant. The derivative of that constant is 0. So this would be our answer for problem 1. Next, problem 2. You have g of x equals 1/3 x cubed minus 3x squared. And what I'm going to do is rewrite this as what I call a calculus-friendly form. So you have this 3 over x squared is going to be 3x to the negative 2 power. And then that, so really so far what I've written is a calculus rewrite. And now to find the first derivative, g prime of x, is you have 1/3 times 3 x to the 3 minus 1, which is 2, minus, well, you have negative 2 times 3 is going to be positive 6 x to the negative 3. So now you have 1/3 of 3 cancel out, so g prime of x is equal to x squared, and then we have plus 6 over x cubed. So that's going to be our answer to problem 2. Problem 3, f of x equals 2x minus 3 over 2x plus 4. What we're going to do is a graphically organized manner that I use on such functions. I have our low function, let's say quotient of two functions, so we use quotient rule. The low function is 2x plus 4, and our derivative of our low is equal to 2. Our high function is equal to 2x minus 3, and our derivative of our high is equal to 2. And so now we have f prime of x is equal to low d high minus high d low all over low squared. So 2x plus 4 squared. And now really it's a matter of simplification. F prime of x is equal to, you have 2 times 2x, so that's going to be 4x. And 4 times 2 is going to be 8. And you have minus 2 times 4x, so that's going to be minus 4x. And you're going to have minus minus, there's a minus and a minus here, 2 times 3, so that's going to be plus 6. And you're going to have over 2x plus 0.2x plus 4 squared. And you have cancellations going here, 4x, 4x. And so left for that, you have, okay, 8 plus 6 is 14 over 0.2x plus 4 squared. And so that will be your answer. One thing you look for is if you have these functions in terms of x, like x to the first power, you're going to end up with a derivative with simply a number, either positive or negative, in the numerator, and then your denominator squared as your first derivative. So this will be our answer. Next, problem 4. Now this one, f of x equals 2x times quantity x squared minus 3 to the 5th power. I had a student who tried to simplify this by distributing. But why can you not distribute? Because the reason you can't distribute is you have to the 5th power. And so you have a choice to make. In this instance, you can go ahead and expand this out to the 5th power. And I don't recommend doing that at all. What I recommend doing is considering this expression here as a product of two functions. And the way I've done that in this class to organize. And when I organize like this, what I'm inviting the student to do is become like a calculus machine. So I'm put u prime, v prime here. And so u is going to be 2x, and u prime is 2. V is going to be quantity x squared minus 3 to the 5th power, and v prime is going to be 5 times x squared minus 3 to the 4th power times the derivative of the inside, which is the derivative of x squared minus 2, so that's going to be 2x. And so what that's going to simplify to for v prime, I'm going to write down below here, it's going to have 10x times quantity x squared minus 3 to the 4th power. So our answer is going to be u v prime, which we can multiply these together, plus v u prime. And so we have f prime of x is equal to u v prime. So I have 10x times 2x. So that's going to be 20x squared, x squared minus 3 to the 4th power, plus this multiplied together, we have 2 times x squared minus 3, make sure I want to see the 5th power. And you could factor out x squared, like 2x squared minus 3 to the 4th power, and get some kind of expression like that, but this will be sufficient for what I'm looking for in this. Next, 5. Find the first derivative of each function. I'm going to do a calculus-friendly rewrite. I have 2 times 3x minus 2 to the 1/2 power. And so our derivative h prime of x is going to be 2 times 1/2, and we're going to have 3x minus 2, and 1/2 minus 1 is going to be negative 1/2 power, times the derivative of the inside, which is 3. And then we have 1/2 of 2 cancel each other, so h prime of x is equal to, we have this 3 sitting up here in the numerator. In the denominator, we have the square root of this 3x minus 2, negative 1/2 power is going to be in the denominator, 3x minus 2 squared like that. So I think that should be the entirety of it. Does that look right? Yeah, I think that's right. Okay, next, 6. We have a 4th root of g of fx equals the 4th root of 3x. So that's going to be 3x to the 1/4 power. And so f prime of x is equal to 1/4 of 3x. If we subtract 1, we're going to get negative 3/4. Negative 3/4 times the derivative of the inside, which is 3. So for that, we get f prime of x is equal to, we have 3, that's in the numerator here, over 4, and we're going to have a fourth root here of 3x, and we have to the, that's going to be to the third power down here. So that will be your most simplified version down here. Now, if you went ahead and kind of left it unsimplified here and all that, I can understand that that'd be, as a matter of technicality, a correct answer. But you should really try to get it back into the original form, which would be there's a radical form here, so you want to put your answer in the radical form if at all possible. So these problems 1 through 6 are really key in that they are a smattering of the types of to the power of x derivative skills that are necessary to go anywhere in this course. So if you didn't find yourself able to do those things handily, there's a lot more work to be done there. Next page, test to see if a function below is continuous and differentiable for all x. Justify. Well, what you have is g of x equals x plus 1 when x is greater than or equal to 1, and x squared plus 1 when x is less than 1. And so first of all, for continuity, I'm just going to put CONT. We're going to test limits, and we know we have a critical number, if you want to call it that, of 1. Critical number equals 1. So for continuity, we already know the function exists. So if we use the three-step process, we say g of 1 exists and is equal to, well, it's equal here. We have 1 plus 2, no, 1 plus 1. 1 plus 1 equals 2. So next we test for the limit, see if the limit exists. That's step 2. We say limit from the left, so limit as x approaches 1 from the left side of fx, g of x equals limit as x approaches 1 from the right side of g of x. Now we already know that from the right, it's going to be the same as when we plugged in for the limit here. So we know our right side's already going to be 2. On the left side, we don't know what it is yet, but we have x squared, which is 1 squared plus 1. So we end up with 2 equals 2. So we say the limit as x approaches 1 of g of x exists, n equals 2. Well, since step 3, since g of 1 equals limit as x approaches 1 of g of x, g of x is continuous, okay, for all x, because that's the only point of question. Next, to the right, we've assessed that. We're going to go to differentiability. I'll spell it out. Ability. And what that is, it's very similar to the continuity one on the left. It's going to be g, it's going to be limit as x approaches 1 from the left side, not of g of x, but of g prime of x, equals limit as x approaches 1 from the right side, not of g of x, but of g prime of x. And so we're going to take the first derivative of both sides. And so on the left side, we have this x squared plus 1. So our derivative of that is going to be 2x. Right? Derivative of x squared plus 1 is 2x. And on the right side, we have the derivative of x plus 1 is going to be 1. And now if we plug in 1 for each of those, we have 2 times 1 equals 1. Does 2 equal 1? No, it does not. Okay, since limit as x approaches 1 of g prime of x does not exist, g of x is not differentiable if at x equals 1. So you have continuous for all x, but not differentiable. So not differentiable for at x equals 1. Has g of x is differentiable? Should be is not differentiable. So I said it right. Is not differentiable. Okay, next. A table showing certain values for f of x is shown below. What is the limit as x approaches 3 of f of x? And you see that we're getting, there's a mistake on this. Should be limit as x approaches 4, shouldn't it be? I don't know if I had that right on the test, but it should be as x approaches 4. I'm going to see if I made a typo on that actual test. But yeah, you're approaching from the left and the right. You're both approaching from the left side. So limit as x approaches 4 from the left side of f of x is equal to, from the left side, it's going to be, looks like we're approaching 4, right? And limit as x approaches 4 from the right side of f of x is also 4. So left-hand limit equals right-hand limit equals 4. So our answer to this question is 4. I think a lot of people got this one right. Next, 9. The function v of t over the interval a, b is continuous, represents velocity of a particle if v of a equals 1 and v of b equals -2 and f of c equals k for an input value of c on the interval. What is the value of k that guarantees? Okay, guarantees is the same as must or at least. Okay, at least is with that, right? What this is usually a theorem. So it's usually like the mean value theorem or intermediate value theorem. Okay, so it should give you that type of representation. So the way I would look at this is kind of look at a graph. So if we take a graph of this, and we say, okay, we're going to go look at this and say, okay, v of a equals 1. So here at a, we have v of a, which is equal to 1. So we are right at this point. And v of b equals -2. So here at b, we have -2. And so where x equals b, so we have these 2 points here at a comma 1 and at b comma -2. For an input value c on the interval AB, so somewhere in here there's an input value c, what is the value of k that guarantees? And so we say f of c equals k, so you're talking about y value that guarantees that the speed of the particle will be exactly 4 at least twice. And so up here, and this is tricky here, because to have a speed of 4, we can do it one of 2 ways. We can come here to a value of -4 down below the x-axis, or +4 up above the x-axis. And so what is the value of k? Well, we can try different things here, and I'm going to go ahead and go to a red thing. So if we try 4, I'm looking at c here, and come up here, we can, if that's k, well, then we can come up here and touch this, and then go down, and then we've reached a speed of 4 exactly once. Now, could the thing go over 4 and go down and meet it twice? Yeah, it could, but we can't guarantee that. And so we have, this is not a correct answer. And then the next thing, 0, well, 0, if we go to 0, we don't have any kind of guarantee at all. So that's not going to work either. Okay, now, so we have those that are off the table. Next, we have -5. So if we have f of c equals -5, well, here we go. Like, we know to get to -5, we're going to have to cross a speed of 4. Now, it says -4, but the speed is the absolute value of velocity. And then we have to come through. So the intermediate value theorem tells us, okay, if this is c comma -5, we know we have to cross the speed at least twice. So C is our correct answer. And then we can eliminate D. If we go to 3 here, we'd realize we wouldn't have to even hit it once. If we took -3, we'd realize that we wouldn't even have to touch once. So definitely C is our correct answer. Next, and for the function f(x) equals 2x squared minus 14x, find the equation of tangent line at the point where f prime of x equals 10. 2 points. So we need an equation, and we do not. What do we need for an equation? We need a point, which is an xy coordinate, and we need a slope. Well, this is one of these instances where we are given a slope. So slope is going to be m of t is equal to 10. That is our slope. So we just need to find what our point is, and then we'll be okay. Well, first of all, I'll take f prime of x is equal to, taking the derivative, we have 2 times 2, which is 4, x minus 14. And so now, if we just set this equal to 10, so I'm going to say f prime of x is 10, so 10 equals 4x minus 14. We can solve for x. So we have 4x is equal to 24. And dividing, we have x is equal to 6. So that's our x coordinate. There we go. And then we can find f of 6 by plugging into the original equation. So we have 2 times 6 squared minus 14 times 6. And 2 times 6 squared, that's going to be 2 times 36, or 72. I'm going to subtract out what's 14 times 6. I'm going to put out here, we got 24 and 2 to 6 times 1, 8, 84. So that's going to be -12, is that right? So -12. So our equation is going to be y minus -12 equals m. 10 is already m. X minus 6. So there's our answer. I don't know if this problem was printed in the version of the test that you just had, but I think it's a good problem. Next, 11. For the function fx equals square root of quantity x plus 2, tell whether relative theorem or mean value theorem applies on the interval from -2 to 7. If so, find the value of c that satisfies the conclusion of Rolle's theorem or the mean value theorem. So for this one, I'm going to say, okay, we're going to say AB, right? So we'll say AB, f of A equals f of -2, which equals square root of -2 plus 2, and that's the square root of 0, which equals 0. F of b is going to be f of 7, which equals square root of 27 plus 2, which is square root of 9, which equals 3. So f of b is 3. And so the average rate of change is equal to f of b minus f of a over b minus a. In this case, we have f of b is 3 minus f of a is 0 over b minus a, and b is 7 and a is minus -2. So we have 3 over 9, which is 1/3. So that's our average rate of change. So now it says, okay, which applies here? Well, not Rolle's theorem, because f of b is not the same as f of a. So MVT applies, since f of b is not equal to f of a. But what else? Also, and f of x is continuous and differentiable on the interval of -2 to 7. Now, I notice I parenthesized instead of bracketized here. That's because in finding a derivative, we're going to need to take the open interval. So, since the mean value theorem does apply, we're going to go ahead and take the first derivative here. So f of x is equal to x plus 2 to the 1/2 power. So f prime of x is equal to 1/2 x plus 2 to the -1/2 power, which equals, and also times the derivative of this inside here, chain rule, which is 1. So we're going to have here is 1 over 2 square root of x plus 2. And what we're going to do is set this equal to 1/3, right? Because we've got a rock equals I rock, so this is I rock. So we're going to say 1/3 equals 1 over 2 square root of x plus 2. And just working through here, we have 1 over 1 on the top, so we have 2 square root of x plus 2 is equal to 3. And so if we divide by 2, we get 3/2. So we get square root of x plus 2 equals 3/2. And squaring both sides, we get x plus 2 equals 9 over 4. Then subtracting 2, we get, I'm going to go right here, x is equal to 1/4. So what is that? It says find the value of c. So we will say c is equal to 1/4. So that's our answer to this problem here. Okay. Next, let's go on to number 12. For the function g of x equals the square root of absolute value of x minus 2, g of -3 equals 1. Tell if Rolle's theorem applies. Well, we have, it would be like -3 to 3 would be like AB, right? Well, we would have f of b is equal to g of 3 equals 1, and f of a is going to be -3 is equal to 1. So f of b equals f of a, that's Rolle's theorem. Okay, so it would apply there. But Rolle's theorem does not apply Why does Rolle's theorem not apply? Simply, this is an absolute value function. So we have a square root of x minus 2. So here we have, absolute value is its square root. Absolute value of x minus 2. So that's what this thing looks like, right? Okay, and then we have negative 3, 3. But what do we have? Not differentiable. So since g of x is not differentiable, is continuous, right? Differentiable on the open interval from negative 3 to 3, Rolle's theorem does not apply. But doesn't. If I can spell doesn't, that would be nice. Doesn't apply. Okay, so that's number 12. Next, 13. For the function fx equals x squared minus 4, find the equation of the normal line. And I instructed my students here, instead of normal line here, to instead substitute the word tangent. And tangent coincides better with the standards of AP testing, so that's why I made that little change. And so the point where x equals 2, you want the equation of the line. So we need two things. Point and our point is the x-coordinate 2. We will find that y-coordinate. Well, to find that y-coordinate, if we put f of 2 to the original equation, we're going to have 2 squared minus 4, and 2 squared minus 4 is going to be 0. So 0 is our other point here. Our coordinates, the y-coordinate. And then finally, for f prime of x, we're going to take 2x. That's it, really, right? 2x. And f prime of 2, if we put in here, we get 2 times 2 equal 4. So that's going to be the slope of our tangent line. So slope m of t is equal to 4. So our equation is going to be y minus y1, which is 0, is equal to our slope, which is 4, times x minus x1. And then if you distribute here, you're going to get 4x minus 8. And either one of these forms would be perfectly fine as an answer. So next, problem 14. The table below has recordings of the depth of the river above flood station during 18 hours of recent rain. What was the estimate of the rate of water level increase at t equals 10 hours? Well, really, a table can be used to test intermediate value theorem, mean value theorem, or an estimate of a rate, right? Estimate of rate of water. An estimate of rate of water is found by taking average rate of change. And what you do, you want to find at t equals 10 hours. Well, do we have 10 hours? No, we don't, but we know 10 is going to be somewhere between t equals 9 and t equals 12. So we're going to use these two points here. So we're going to say f of 9 is A, and f of B is 12. And so 15 is going to be f of A, and 17 is going to be f of B. And so A rock is going to be f of B, which is 17, minus f of A, which is 15, over B minus A, which is 12, minus 9. So I'm going to get we're going to get 2/3. And it says state the proper units. We're going to have feet. The change in feet per hour, so it's going to be feet per hour. So that's going to be our answer, 2/3 feet per hour. And one thing you do is you check signs. Okay, well, it looks like the depth is still increasing over this interval. So that is going to be a positive 2/3 foot per hour. And it's really your best estimate given the values that you have. So you got to look for that situation. Okay, good. What is the limit as x approaches infinity of negative of 5x to the fourth power plus 3x squared plus 10,000 over 2x squared minus 2x to the fourth power? Well, this limit as x approaches infinity is related to the horizontal asymptote. And for this, I have a little acronym that I've used here, BETC, BOBO, BO2. It only applies for limits to infinity. And if the bottom top equals top, so you have x to the fourth down below here, and those are the highest powers. So you have used coefficients. So what you have is your answer for this limit is going to be negative 5 x to the fourth over negative 2 x to the fourth, and really the x to the fourth or x to the fourth cancel each other. So you have negative 5 over negative 2, which simplifies to 5 halves. So 5 halves is our answer for this. Should be quite simple. Okay, 16, what is the limit as x approaches 5 of x minus 5 over x squared plus 4x minus 45? What you're going to have when you plug in 5, first step, you have 5 minus 5, which is going to be equal to 0 in the numerator. In the denominator, you have 5 squared plus 4 times 5, so that's going to be 25 plus 20 minus 45. So you're going to get 0 over 0. Like I tell my students here, once you have that, you got 0 over 0, you have more work. And what you're going to do is a simplification, and to have this be 0, over 0, you have to have a factor of x minus 5 in the denominator. And what times x minus 5 equals x squared plus 4x minus 45? Well, it's going to be x plus 9, is it? Yeah, it is. And you have cancellation here. So our answer is going to be our limit as x approaches 5 of 1 over x plus 9. And so if we substitute in for x, we're going to have 1 over 14. So 1/14 is our answer for this particular limit. So that's that one. 17, find the horizontal tangent line or lines, if any, to the graph of the function f(x) equals 1/2 x squared minus 2x. And so what you want to do is take your first derivative of this function here, which we're going to have 2 times 1/2 x to the first power, right? So that's minus 2. So that's going to simplify to 2 times 1/2. So you can have x minus 2. And so we set that equals 0. So we say instead of f prime of x, we set that to 0 to get our horizontal tangent line equals x minus 2. And so x is equal to 2. So for this one, our point is x equals 2 and y equals, well, f of 2 is equal to 1/2 times 2 squared minus 2 times 2. So we're going to have 1/2 of 4, which is going to be 2 minus 4, which equals negative 2. So that's going to be 2 comma negative 2. And we know our slope is 0, so slope is equal to 0. Horizontal tangent line is going to be a y equals. So we have a y is equal to negative 2 is our horizontal tangent line. Okay, So that's our answer here for number 17. Number 18, what is the limit as h approaches 0 of this thing up here? Well, this has to do with the definition of a derivative. So definition of a derivative is equal to limit as h approaches, I put x, I'm going to put h. Messed this up here. Okay, limit. Okay. I'm messing this thing up to smithereens. Okay, limit as h approaches 0 of f of x plus h minus f of x over h. And so what this tells you is you have this minus here. So in this instance, you have f of x is equal to 3x squared minus 2x. In this manner, we don't have to go ahead and distribute this thing to death. We can just go ahead and take the first derivative of this and we have our answer. So f prime of x is equal to 6x minus 2. And so we would just go up here and say equals 6x minus 2, which is our first derivative, using our definition of derivative and understanding of what a first derivative is and where to place that. That should be a quite easy problem. Next. So this is where I added a problem. Okay, use the graph of h of x. Make sure I got this right. 18, okay, here's 19. Okay, use the graph of h of x to answer problems 19 through 24, 1 point each. What's the limit as h approaches negative 4 of h of x? Well, here's h approaching negative 4, right? So it looks like our value is negative 4. So let's say negative 4 will be our value. Next, 20. What is h of negative 1? So we go over here to negative 1. It looks like we're right on the x-axis. So we say that's going to be equal to 0. And that's just using the best judgment we have. Next, 21. What is limit? The limit as h approaches 2 of h of x. Well, here we have our limit not being the same from both sides. So the limit as x approaches 2 of h of x, we say since the left-hand limit does not equal right-hand limit, we will say that limit does not exist. Now you notice I erased that equal sign because it's not equals does not exist. It does not exist. When you put equals, that is sort of a double, that's a double verb and not linguistically consistent. What is h of 2? Well, here we don't have a limit, but we do have a value. So that's going to be equal to 4, right? Because that's the filled in circle. So h of 2 is 4. Next, what is the limit as x approaches 4 of h of x? Well, right here, it looks like we're stuck right here in some kind of vertical asymptote. So we will say that limit does not exist. Actually, it approaches infinity, right? From the left and the right. Next, 24. What is h of 4? Well, we don't have h of 4 defined here with any kind of circle, so we will say that also does not exist. Limit does not exist. The h of 4 does not exist either. Next, what is the limit as h approaches infinity, as x approaches infinity of h of x? Well, we can't tell for sure, but it looks like we are coming, looks like you have maybe a horizontal asymptote of 0. So we would say that would be 0, which would be corresponding to a horizontal asymptote of y equals 0. So 0 would be our answer for our best answer for problem 25. Next, 26. What type of discontinuity is evident at x equals 2? Well, you see a big gap here as we go up from one function row to the other. So that would be a jump discontinuity. So if you just write the word jump, that's probably the best answer. Anyway, next problems set 27 through 33. Use the graphs of f of x and g of x to answer problems 27 and 33. What is g of x? I mean g of 4. And so we go to our g function here and go to 4, and we see that we have a value of 2. So our answer for that will be 2, our best answer. Next, what is g prime of 6? So we go to g of 6, and our g prime is our slope of that. And we have a horizontal line segment here, so our g prime of 6 is going to be the slope of this line segment, which is 0. So g prime of 6 is 0. At least that's the best information we have. Next, what is f prime of negative 3? Well, we go over to negative 3 in the f function, and we should see, so it's going to be about right here, we're dealing with this line segment where we have a slope going up of a 1 for 1. So over 3 to the right and up 3. So 3 over 3, m equals 3 over 3 equals 1. So f prime of negative 3 is going to be equal to 1, at least as far as we can tell through the slope of this line segment. Next, what is f prime of 5? Well, here we're on the f side here, and here we are at 5, and you can see that we're at a corner. So in this case, the limit as x approaches 5, the limit as x approaches 5 from the left side of f of x does not, okay, limit as f prime of x on the left side does not equal limit as x approaches 5 from the right side of f prime of x. That's what happens at a corner. So we will say that limit does not exist because the left-hand limit of the prime does not equal the right-hand limit. Now, as far as continuity's sake, the value that would be probably 3, right? But as far as the slope, you have the slope of 0 on this side and the slope of 1 on this side. So we have 0, okay, 0 is not equal to 1. So the slope of 0 on the left is not equal to 1 on the slope of the right. So that's going to be our answer. It does not exist. Number 30. Next, if f of x, if h of x equals f of x times g of x, what is h prime of 2? Well, that's going to be a product of two functions, f times g. So what we can do for that is just like we did earlier in one of our first 6 problems, that set. We say, okay, well, f of 2, so let's go to 2, is equal to 3. So u prime, so that's 2. And what's going to be our slope at x equals 2? I got to go over here. There it is, right? That's f of 2. Wait a second. That's going to be 3, isn't it? Guys. Okay, let's go ahead and go. So we'll call this the f function here. So that's going to be 3. And our slope at x equals 3 is going to be 0. And then for g of x, we have at 2, we have v is going to be 0 because we're right on the x-axis, but our slope is going to be 1. So h prime of 2 is going to be 3 times 1 plus 0 times 0. It's going to be equal to 3. So 3 would be our answer for this problem. Next, if h of x equals fx times g of x, what is h prime of 0? What we're going to have is similar to that last problem. We're going to have u prime, v prime, and I'm going to say uv. And so we'll go to f first for the u, and we go to 0, and I get a value of 3 there, right? So u of 0 is 3, and our slope is going to be 0. And next we get to g. Well, g of 0 is going to be -2, but our g prime here, what is the slope? Well, it's inconclusive because we're at a corner, so it does not exist. So what we have here is h prime of 0 is equal to 3 times does not exist plus -2 times 0, which is 0. And anytime you have any element that does not exist, that disqualifies the whole thing from being differentiable. So we say h prime of 0 does not exist. That is our answer for 32. Next, 33, we have h of x equals g of x over f of x. What is h prime of 6? What we're going to have is h prime of 6 is going to be low, d high, so we're going to say f of 6, and d high is going to be g prime of 6 minus high, and so it's going to be minus g of 6, d low, so we're going to have f prime of 6 all over low squared, so it's going to be f of 6 squared. And so we have, I'm going to work to the right here, f of 6 is going to be equal to 4, and g prime of 6 is 0, right? This is flat, so g prime of 6 is 0, minus g of 6. Well, g of 6 is 2, and g prime of 6, well, that looks like it's going to be a slope of 1 here at this point. 1 all over low squared, and f of 6 is going to be 4, right? 4 squared. So we're going to have -2 over 16. If you want to simplify, you get -1/8. Which will be our answer for number 33. Okay, 34. What is the integral from 0 to 5 of 3x dx? What you have for this is you do not have a horizontal line, my young friends. AB calculus, you have the line 3x. And so that's going to be a rise over run of 3 over 1. And you're going from 0 to 5. So when you go from 0 to 5, you're going to go up 5 times 3, or 15. So what you're looking at is this whole area here, okay, of this triangle. That's what you're looking at. This is your function right here, this line. So our answer for this is going to be the area of a triangle, which is the base, which is 5 times 15 over 2. And so you could leave it like that, or if you go ahead and multiply it, you get 75 over 2. So 75 halves is our answer for number 34. And then 35, what is the intersection of y equals 11 and x equals 4? Well, that's going to be simply the coordinate pair 4, -11. So anything different or more than this is going to be not really a valid answer. And I think, if I'm not mistaken, that's the entirety of that test. Shouldn't have been that bad of a test. It is somewhat comprehensive for what we've been doing through the school year so far. Good luck, study hard on all your assignments, and thanks for viewing.